All right, new recording. We're recording. There we go. Hi everybody. Let's get into this. So the next lecture today, the idea is to talk about world building. So I'm gonna go ahead and um, end this event. Uh, Start the next event. World building. There we go. Start event. And we're going to talk about a lot. What I really want to focus on with world building is talking about how to get the most bang for your buck in the shortest amount of time, like getting visual quality up and getting a landscape set up in a short amount of time, and then um, really making it look nice without having to do too much work. Because I think that that's like what matters for a game jam. So we're going to talk a bit about lighting, a bit about sound. Trigger volumes, volumetrics, post processing, um, AI and nav meshes, foliage, terrains, grass, water, a lot of the systems that are sort of built into Unreal Engine. So I'm gonna start by kind of trying to do a demonstration. I'm gonna go ahead and do new level, and um, I'll do an empty level like this so that we have just a totally empty environment in Unreal Engine to work from. Give me 2 seconds. I'm going to see if I can um, change the editor UI scale. If there's a way for me to do that, that would be pretty cool.
This is just a giant
Let's see.
for tools, where you can scale 1.5.
Widget reflector. I see what I need to open up. Developer tools widget reflector under window, developer tools. See if I can make things just a little bit more easy to work with here. Viewports, world partition. There's a lot of tools that Unreal Engine has available to us. 1 second. World partition, no, no. No.
It was just a regular old empty world you opened, right?
Yes, yes, totally empty world. Totally empty world. Debug, widget reflector, application scale. There we go. There we go. Whew. Nice. Okay, everything is now significantly smaller and less readable, but I can work with it a little bit better. It's nice to have the Unreal Engine GUI be at like 80% size or something. I feel like it's a little too big for my taste by default. And now it's even more like small and usable on my 1440p monitor on my other screen. So that's very pleasant to work with. There we go. Man, God, that's so much nicer. Okay, so landscape. Nice. We've got our landscape. Are things pretty crisp with Discord sharing my screen right now? Is it like still readable, the text?
Yeah, it's true.
Okay, good, good, good. Okay, so I'm gonna delete this stuff, and we're gonna get started. So first things first, we're in the Unreal Editor, and we're in a level right now. So I want to talk a bit about how levels are organized. I did File, New Level. I'm gonna do this again, Empty Level, and now we're in a fresh empty level. This level doesn't like exist in the project's like data yet. It's just in RAM. It's just an environment. The moment that I hit Control S and attempt to save, it asks me save the map. So maps are like the level files in Unreal Engine. And the moment that I save this as like, I don't know, level, we'll do menu underscore level. This will actually save. And then whenever we click on this, it'll take us back to this environment. So this will be like our main menu, I guess. I'm gonna make another level, and I'm gonna call this, I'm gonna use the basic level just to keep it different. And again, this is totally in memory right now. So if I like move things around, I do stuff, it's not gonna be saved unless I hit Control S. And you can tell by this little asterisk up here. So Control S, and we'll call this game level. And I'm gonna go off of, honestly, I'm gonna try to reproduce this stuff from the other video that we just did. So I'm gonna preface this for the people that were, maybe following along on YouTube. A minute ago, we did like a bit of a level design idea. I'll let you like pause and read this if you're curious. But yeah, I'm going to try to recreate this map and try to put some NPC related features in it and stuff like that for the sake of explaining. So, all right, let's get started. So let me delete this default actor here. I'll go into selection, delete this guy. And let's also look at what came with the level, right? We have this folder up here called lighting. We've got a directional light. It's a great idea to take your time and read what some of these options over here are. There's a lot of options for lights usually, and in my opinion, there's some of the more interesting options in games. Lights and the shadows that they generate are a big part of your performance as well. So right now I'm on scalability cinematic, but if you're trying to make a game that you're confident is going to run on everyone's computer at a game jam, it's good to try to be working on like low or medium settings and try to make things look as good as possible within those constraints. Because if things look good on medium, then they're only going to look better on cinematic quality. I'll put this on epic for now, or perhaps, yeah, epic is fine. And also monitor editor performance, why not? And if we click over here, we can do show FPS. So we'll get a little frame rate thing. We're looking at 120 frames per second right now. That's good. The milliseconds below that is the time between frames. So if there's 8 milliseconds between a frame, that's 120 frames per second. It's like, 1 over frequency. Okay, so the lighting effects. Directional light. This is the sun. Directional light is actually, if we rotate this around, you can see the effect that it's having on the clouds. These volumetric clouds right here are these guys right here. What is the merit of a volumetric cloud if you're not building a flight simulator where you actually fly through the clouds? Like, they're cool, they're aesthetic, but I don't recommend them. They're ray-marched, they're, kind of a performance hit. If I remove these, we're gonna get a little bit more performance out of our environment. We don't really need them. There's better ways to handle them. In fact, if we go over here in the actor, oh, do we not have the sky sphere anymore? That's fine. I guess this is our sky sphere. Excuse me. So, yeah, my bad. Let me zoom back in. So here's the directional light. Exponential height fog. What is this? Exponential height fog is what defines the fog in the environment. So if I drop a static mesh in here, like a cube, and I move this cube down and away from us, he gets sort of, whoa, where'd he go? There we go. Here's our cube. This cube is generating a volumetric shadow. You can kind of see that right here. You see this kind of like patch of it's a little subtle. Let me try to get in the right angle to, there we go. You can see this volumetric shadow right here. Whoop, not there. Here. There's like a patch of darkness. You can kind of see that contrast right there.
Oh, yeah.
Yeah, that shadow, there we go, it's kind of sharp there, is, yeah, you see what's going on? That is inside of the exponential height fog. So this is volumetric lighting that kicks in below a certain level. If I move this actor up, like so, it actually brings the fog up with it. And this fog is, as the name would suggest, exponential with height. So let me actually add a landscape to better display this. I'm going to go click landscape, and I'm going to do create. There we go. And now in the distance, you can see the landscape is kind of being fogged. It's getting hazy and blue. But if we have like a mountain or something, at the top of this mountain, things are pretty crisp. And if I go back to selection mode so I can move things around, and I grab the exponential height fog, which is down here, and I raise this guy, he's going to pull up the fog with him, such that, yeah, things are getting a little bit foggy down there. If I go over here and I increase the fog density and the fog height fall off, you can see what that's kind of doing. We can play around with that. So the fog starts at the altitude of this thing. If I set it to a height of 0, now it's sitting at 0, 0 globally. I'll also put it at the 0, 0 coordinates in terms of x and y. And there we go. So pretty dense fog. It's actually by default not fully volumetric. It's only like faking the volumetric effects. If I actually check this box here, it says volumetric. It will do a much more accurate job of simulating the volumetric lighting. So see now, when I'm looking at this hill, you can really tell the fog effect. But the moment that I get into this dark area where light isn't scattering off of like dust in the air, it's pretty clear. Things are clear in front of me. So that's the volumetrics like actually being simulated. Volumetric lighting is anything that has to do with like fog, or maybe underwater you would have really strong volumetrics. We can see, you see these shadows over here on the side of the mountain. We can see this sort of like line of contrast right here. There we go. That's volumetric lighting at work. So really, you just have to be familiar with some of the settings here, but this can give you some really impressive visual effects. Volumetric lighting is relatively expensive computationally. So, and if I also play with this scattering distribution stuff and extinction scale, we can kind of change exactly how it works. For instance, your scattering distribution kind of changes like it actually explains how this works. Controls the scattering phase function, how much incoming light scatters in various directions. 0 scatters equally in all directions, while 0.9 scatters in the light direction. So if we have this at 0, it doesn't really matter if we're like looking straight at the sun. The fog effect is the same. But if I change this to 1, you can sort of see that we get more of a God ray effect. But when we're not looking at the sun, we don't really get almost any of that fogging. It's only when we're looking at the sun that we get more of the fogging. So, yeah, this is what that's doing. Albedo, emissive, extinction scale, this kind of describes the density. So if I crank that up and I set this to 0, we get extremely dense fog. The moment that we're inside of the like penumbra or the shadow of the mountain, whatever. Yeah, I'll change this extinction scale back to 1. View distance, start distance. So you can crank up a start distance, and this just keeps things near you perfectly crisp. So it only starts, right now it's set to 2300. So remember, Unreal Engine units are in centimeters. So this would be, what, 23 meters away? Because 100 centimeters is a unit. It's a meter. So if I set this to 100, it starts at 1 meter away from my face. So if I'm closer than a meter to an object, I'm seeing it clearly. There's no fog. What else? What else to talk about? Yeah, this is, I guess, everything to do with exponential height fog. There's also other types of fog. We can click over here and do local height fog. And local height fog is just like, look at that. It's a chunk of fog. Clouds. Fat clouds. Yeah, we can give this some effects. We can give it a sphere effect where it like fades in from the outside, local height fog, whatever. And you could probably use this to like isolate chunks of your world to have a bit of fogging. If you wanted to create a interesting effect, you could create a particle system that is moving a bunch of these like spheres around in like a swampy area, and you get these little clouds of fog hovering around. It's a complicated effect to produce. That would fall under the area of technical art. But yeah, you totally could. You totally could. Okay, so I've covered some of that. In fact, I'm going to click on visual effects because that's what we're really focusing on today. Volumetric clouds, we talked about those a little bit, but we deleted them because they're kind of just the clouds in the sky. They're not too special. Under directional light, let's talk a little bit more about lighting and the significance of different lighting effects. So Unreal Engine, as of Unreal Engine 5, has a few different ways to do lighting. There's Lumen. So right now I have ray tracing enabled actually. Whoa, we got the really bright fog effect there. Okay, so we're in the shadow of this cube, but we're still getting light. You know, the ground here isn't pitch black. Where is that light coming from? Well, some of it's coming from Skylight. So what Skylight is doing is it's taking a 360-degree picture of our world, and it is reprojecting the top hemisphere of that picture down into the ground. It's like saying, hey, this is the color of the sky right now. Let me create this sort of global lighting effect that illuminates the environment. Let's see what happens when we play with the intensity. If I go down here and I turn down the intensity to 0, this is the world with no skylight affecting us. If I turn this back up to 1, that's the skylight effect. It's taking the ambient light of the sky, which it thinks is blue, and it's kind of painting it onto the ground. If I crank it up, it's going to take a second for the exposure to reset. But yeah, now the world is extremely bright, and the exposure simulation in Unreal Engine that kind of tries to pretend that we're looking through a human eye has adjusted for that brightness, and now we're looking at just the color of the sky being kind of painted onto the world. So I'm going to turn this back to 1, and everything's dark, and it's like we just got flashbanged, and our eyes start working again. If I were to go to the sky sphere, and the sky sphere is actually sampling the orientation of our directional light, so it knows where the sun is. If I rotate the directional light such that we're looking at, sunset roughly, like that, then the skylight is resampling what the sky looks like. If I disable real-time capture, it's capturing the scene, but now that I've disabled that, it's not going to update on its own until I click recapture. So if I move this light back up, if I move the directional light back up, now the directional light is pointing up, but the shadows are still dark and actually ever so slightly red. I don't know if you guys can tell, but the second that I click recapture on the skylight, it's going to look, and now they're blue. And that's because it recaptured the top hemisphere of the environment. So that's how the skylight works. The skylight also has a couple of other pretty key effects. Unreal Engine, one of the biggest edges that it has in visuals and graphics is that it made distance fields a very key part of the engine. What are distance fields? It's a little easier to show you than to tell you. So let's go ahead and do show visualize distance field, global distance field. Here's the global distance field. Interesting, right? We're looking at this weird kind of blob of the environment. What distance fields are is they describe a shell around various objects. Like here's a cone. So I just put the cone in the world. And it's looking at that cone mesh, and it's generating a blob around it. These blobs indicate a set of points that are equidistant to the surface of the object. So with this cone over here, every point on the surface of this blob that we're looking at is close to the cone. This graphic technology is really important because it allows the engine to optimize certain lighting effects, like certain ray casts, because it doesn't have to... It knows how close a ray is to the surface of an object by looking up the distance field at that point. And this is the technology behind a lot of the impressive lighting inside of Unreal Engine. Anytime that you import a static mesh into Unreal, distance fields get generated. So for instance, if I import from my desktop the jet glider that we've worked with in the past, it generates distance fields for it. So here's the jet glider, and you can see we get this kind of blob of the mesh. These distance fields allow for lighting effects like lumen. Lumen is the software ray tracing solution that Unreal Engine has. Let me actually develop this. They're disabled distance fields. There's also distance field ambient occlusion. So what I was going at with this is if we go to Skylight and we scroll down here, we can see there's a whole area for distance field ambient occlusion. It's on by default, I think. Turn this back to real-time capture. However, we can turn it off if we turn down the occlusion exponent. If we turn up the occlusion exponent, like you don't really see the effect. It's not that pronounced, but if I put some cubes down here, the thing is there's a lot of different like lighting tech that is interacting right now. Maybe if I put another cube like this, and we're actually already seeing some of the ray tracing effects. This light that we're seeing right here is bouncing off of this surface. That's why we're seeing that. Let me get some of these objects out of the way of, there we go. Cool. Let me do this like that, and maybe a little bit of this. Okay, so, ooh, there's some light leaking through. Let's do this. Okay, so now we're inside of here. If I go to the skylight and I play with the intensity here, we can turn up the occlusion exponent. Let's see, occlusion max distance, occlusion contrast. Let's do 10. Ooh, not quite doing it. Is the alpha set to 1? It is. OCM multiply. Interesting. We're not actually seeing that potent of an effect from it. I have a feeling that this has to do with lumen, and the fact that ray tracing is on. If I try to tweak some of these settings, so where are these settings? If you go to Windows, this is a pretty key detail here. Actually, I really want to emphasize this. If you go to Window, there's a window that you should have open, and it's the world details. Oh, not world partition. Oh God. I think that's what did I open? I opened the outliner. It's down here somewhere. Excuse me. World settings. Sorry. So I usually like to keep this adjacent to the details panel here. This tab is not open by default, but world settings has a lot of the lighting settings. So if we go under light mass is what Unreal Engine calls its baking solution. So baked lighting is when you paint the light onto the surfaces, pre-compute it. But if you check this box that says no pre-computed lighting, it'll force no baked lighting. So everything will be dynamically calculated. Shadows and stuff will be completely dynamic. This is what you do when you want to have like really dynamic lighting, like a time of day cycle or something. Okay. Distance field ambient occlusion. I'm struggling to highlight what that looks like, and I think it's because ray tracing is getting in our way. But if we had ray tracing disabled, which you probably want for a game jam just to increase the accessibility. Let's see. Ray tracing. Use hardware ray tracing disabled. Support hardware ray tracing disabled. Let's also go to lumen and dynamic global illumination. None. And no reflections. And there we go. If I restart the engine now without lumen enabled, we're going to see what that looks like. It's still initializing. Here we go. It's on my other monitor. 86%, 90%, and she's open. Okay, here's our environment. Oh no, where did our level go? The level's down here. We gotta double click game level, and there we go. Okay, here's the environment without like ray tracing. There we go. These black splotches are being created by distance field ambient occlusion. So this is a really performant technique for doing ambient occlusion. Let me turn the settings to something a little bit more realistic, right? So if I go down here and I turn down the occlusion exponent to like 1, to 1, and the contrast, I can turn this down, and the occlusion max distance can be like whatever the default setting was. There we go. These like splotches that we're seeing here of lighting are an attempt to vaguely simulate distance field ambient occlusion, or ambient occlusion in general. What exactly is ambient occlusion? It's whenever you have these like shadows at the edges of objects. There's different ambient occlusion techniques that are working together, and it's one of the most important lighting effects. Let me put some more boxes here so that we can appreciate some of these. Ambient occlusion. There's ambient occlusion happening here. The fact that this edge is darkened a little bit. So let me show detail lighting. This is looking at the world with only lighting. Maybe if I show exclusively, let's do lit, and then show light types, lighting components. If I uncheck everything but ambient occlusion, oh, come on, light types, global illumination, specular. So this is what we're looking at when we're working with only ambient occlusion. It's this kind of layer of the lighting. We're looking at, you know, where light kind of seeps into crevices or not. This isn't doing a great job of visualizing it, but yeah, we'll just
It's almost like the light that passes by your face but doesn't go directly into your eyes.
yeah. I mean, to give you a technical breakdown, like ambient occlusion is supposed to simulate like where crevices and light doesn't get in. Like here's the surface of an object, here's the sun, and the sun is shining. There's sun rays hitting the surface of this object all over the place. But, you know, some of them are going to bounce. But if the surface of this object has like a gap in it, if it has a crevice like this, there's a lower probability that a ray is going to bounce inside of it like that. So what you end up with is this sort of progressive darkness in here, where it gets darker as we get into this crack. The way ambient occlusion is simulated in games is it's done in screen space usually. So what your screen is doing is let me show you. This is actually pretty cool. Here's all the different buffers that a render is spitting out. The one that it's looking at is it's looking at normals, world normals. So if I show you the world normal buffer, world normal, this, every pixel on our screen right now, the color of that pixel is in terms of the global direction that the surface is facing. So every time that we're seeing like bluish colors or this kind of purple, that's because we're looking at pixels that are colored XYZ 001, or actually 0.5, 0.5, 1, which is to say pixels that are pointing up and not sideways whatsoever. So it's looking at this like effect on my screen. It's looking at points of contrast. So where do edges meet between objects that are facing in very different directions? So there's like a 90-degree, you know, between this surface, which has vectors going like this, and this surface, which has vectors going like this. It finds this line, which is a point of contrast, and it paints in darkness along this line. That's how screen space ambient occlusion works. And it's doing it, but it's a very subtle effect. We can crank it up. So actually, I'll use this as an opportunity to talk about post-processing. So in Unreal Engine, when you want to control post-processing, there's two layers where this happens. One layer is in the camera, but right now we're in the editor, so it's difficult to visualize that. The other layer is in post-process volumes. So this is a post-process volume. It's just a volume, but if we're inside of it, certain effects are applied to us. So this post-process volume exposes all the different post-processing that you could possibly be doing in Unreal Engine. There's so much stuff, right? There's really a lot of effects here, and they add a lot of visual quality to your game. Let me collapse these so you can see just how many cool settings there are. Scroll this up. Yeah, get a load of this. Look at all these settings. We've got exposure. So we've got bloom. Let's look at bloom. If I click method, convolution, intensity, crank it up, threshold. Oh, can we crank down the threshold? No, that's right. Convolution doesn't use the threshold, if I remember correctly. If we look at the sun, yeah, nothing's happening. But once I look inside of the box, notice the change that has taken place. Look at the sun. The sun changes. So bloom. Here we go back to standard intensity. That's bloom. Bloom is like the glow of bright surfaces on our screen. And if we turn down the threshold, we get more of it. Convolution is, here we go. This is what I was looking for. Convolution scale. Can we do convolution boost min? Crank this up. Convolution boost max. Convolution multiplier. Convolution buffer. Man, I'm actually not seeing much happening from this. Uh, the convolution bloom is an effect that they recently added. Not getting much out of it. That's kind of crazy. It lets you. It's really cool here. I'll put a point light over here and make it really bright so that we get some crazy bloom. Let me make this smaller. Like so. Ooh, is this really the effect that we're getting? Oh no. Let me go back to the selection mode. So, but in general, whenever you see bloom, you should think, yeah, this is the bloom effect at work. It's the thing that's making those pixels glow. It's calculated in screen space. So the second that the light is off of our screen, no glow. But the moment that we get some bright pixels in the screen, they start creating this blurred glow effect. That's bloom. That's bloom. It's the effect that makes brightness and things that are bright glow. You can set a threshold for it so that darker things don't fire off the effect, but brighter things do. If we make it convolution... Oh, there we go! That's what was missing. There we go. There's convolutional bloom. Excuse me. This is... let's go back and reset these properties down here to something a little bit more normal. Whoa, there we go. Everything is crazy intense. Okay, reset this. Turn down the intensity. There we go. This is convolutional bloom. So this isn't really a really sharp point, but the effect here is, it splits the RGB values of the light to simulate real life a little bit more directly. So we get these like cool rays coming out of the sun. It's, in general, bloom is a very cool effect. Just take my word for it. So bloom. First effect that we're going to talk about, bloom. Next effect, exposure. If you're making a game and you want the game to run at nighttime, when you turn off the light in Unreal Engine, if we go and select the select the directional light and we turn down the intensity of the directional light, which is our main source of light in the world, we turn down the intensity to not 10 lux to like 0.1 lux. This is supposed to be nighttime, but watch what happens over the next few seconds. My eyes adjust. In Unreal Engine, there's like a simulated eye, and it has adjusted. So while we're inside of here, let's go under exposure, and we can turn the max value down. And what this is doing is it's saying, oh, actually, let's turn up the min EV instead. There we go. So this is reducing how bright our eyes can get. This is like disabling our cat-like night vision that gives us crazy night vision ability. And now we're actually looking at things like it's nighttime. If we increase the speed that our eyes adjust, we'll see that they adjust very quickly. Zoop. And you can actually, there's tools. So if we go under lit, there's an area over here, if I remember correctly, that lets us play with exposure and helps us work with it. If we go under post-processing, you can disable exposure, but there's, under developer, there's somewhere in here there's an exposure setting that lets you visualize the exposure effect and actually experiment with it and better understand what's going on. So exposure, pretty cool. Chromatic aberration. Chromatic aberration stretches the RGB values at the edge of your screen. Pretty cool effect. It looks like you're looking through a camera. You see the RGB split that's going on. We can also turn up the offset, so see where it starts. It starts towards the edge of the screen. Very nice, very aesthetic effect. Dirt mask. Dirt mask is one of the coolest effects in my opinion. We have to load an image file for this. What dirt mask does, have any of you guys ever played Asphalt 8 on your phone? Anyone?
Can't say I have.
No? Maybe Battlefield 4 or Battlefield 3? Anyone?
Oh yeah, I played Battlefield 4.
All right. So, let's look at some Battlefield 3 gameplay for a second. Battlefield 3 had this effect cranked up to like 11. Battlefield 3 gameplay. What the dirt mask does is it just creates a texture on your screen that captures bloom and cranks it up like dirt on your screen. Okay, we're not seeing it right here, but I guess this is like a nighttime level. Let's go to daytime and multiplayer or something. Here we go. Oh, the desert environment. Yes, they definitely had it here. It's kind of like having stuff on your visor. Ah, here we go. Here we go. You see these patches right here? All these little patches on the screen of like, oh, okay, come on, go
Like
back.
the light spots.
The light spots, yeah, it's like having like little droplets of dirt or water on your screen. Very aesthetic effect. And it's so easy to turn on. You just import like a dirt texture and it just works. We'll see it. Here it is. See these right here on the left
Yeah.
under smoke ready. Yeah, it just finds bright spots on your surface of or bright spots on your screen and it overlays it. I'm not gonna mess with it too much right now. Under camera, we can change things like shutter speed and simulate all these cinematic aspects of a camera. F-stop, so we can play with like depth of field. I'm not actually gonna play with this. I think this only works if you have cinematic depth of field enabled. Doesn't really matter. Local exposure, lens flares. So lens flares, there we go. That's a lens flare. Turn it off, turn it on, right? Lens flares. Lens flares are a pretty cool effect. They multiply with bloom. You can turn up the threshold required to generate them. If you turn down the threshold, you're creating a lens flare of essentially everything on your screen. So that's what we're seeing right now. Is like every single pixel of the screen is generating and contributing to the lens flare effect. Which, yeah. Oh, look at that. When I look straight at the mountain, my screen darkens like crazy, which is kind of funny. I guess it's something to do with the exposure setting from earlier. Image effects, vignette, right? Vignette, just make the edge of the screen dark. You can tweak this if your character is damaged. You can say turn up the vignette effect. Very small, simple effect, but contributes a lot. A sharpening filter will make things look significantly sharper. It's subtle, but honestly, I feel like this makes a big difference for some games like Arma. You really can tell that Arma has sharpening on by default. Focal distance. Here we go. Ooh, depth of field. We're underwater. We can't see anything. Playing with the focal distance and setting it to like 4 meters in front of us. Yeah. Depth of field. What else we got here? Let's turn this off. Color grading. Color grading is all about like, you know, doing the more artistic kind of post-processing effects, the stuff that's more cinematic. So under color grading, we can do global saturation. We can play with this and kind of, you know, affect the way that our world is colored. If you play with these settings enough, you can get some really interesting aesthetics going where your whole game is like some weird filter. Yeah. You can see, by the way, the post-process volume. When we're inside of it, it has an effect. When we're outside, it doesn't. One of the easiest ways to enable post-processing for your whole game is in the post-process volume, you go to brush settings and you click, post-process volume settings, you click infinite extent. And now it's affecting the entire world. So you just keep one of these in your environment and you check infinite extent and it affects the entire world. Shadows, yeah, you can isolate shadows and we can make shadows like really dark with these post-processing effects. So shadows we can say have like, maybe they're really dark. There we go. Crazy dark shadows or maybe really bright shadows. So this captures just like shadows in the world. Whatever. There's a lot of different effects that you can do by playing with color grading. Film effects. We're not gonna worry about those. These are pretty like, you know, these are post-processing effects that are related to how film actually works. It's just color grading, but with different terms. Global illumination. Notice what happens when I check lumen, right? So I check lumen. If I'm none, no global illumination. Lumen, now we're bouncing rays around. And we're doing this in software, so you don't need like an RTX graphics card for this to work. If I do standalone ray tracing, it's not going to do anything because I have it disabled for the project. Screen space is like a more performant version of lumen, where it only does bounces of light in our screen. So notice what happens. The bottom side of this cube over here is getting illumination only when the bottom of my screen contains these bright surfaces. It's simulating the bounces off of them, but the second that these surfaces exit my screen, we lose that information. So it's only able to calculate light sources that are visible on the screen. That's what, whenever you see the technique that's described as being in screen space, that's what's going on. We can hover over this and like learn what these do. But Lumen is going to be your best solution overall. It just comes with a slight performance hit. Under Lumen Global Illumination, we can control a lot of details over here. We can crank up certain quality values. We can decrease the distance, increase the distance. I'm going to keep that disabled because it's probably expensive. Reflections by default are going to be screen space reflections, but you can have that disabled. Screen space reflections are another screen space technique where the only things that show up in the reflection have to be on your screen. So if you're looking at a mirror and you're looking at like sideways from a really shallow angle, you're going to see the reflections. But if you look at a mirror head on, you're not going to see any reflections because the stuff that it's reflecting is not on your screen. Under rendering features, here's ambient occlusion. We were talking about this earlier. This is screen space ambient occlusion. So if I turn this up to like 10, maybe 100, oh, it's not really letting me, is it? Maybe if I do power, crank that up. Ooh, see that effect? Right here. Focus right there. And we crank up the static fraction, we can like really make the ambient occlusion a lot stronger. This is a very simple effect, but ambient occlusion, I think, is very aesthetic. Here, look at the edge of the mountain, right? We're seeing these really dark spots there. So if I crank up the power, see there's the effect. That's screen space ambient occlusion at work. It only works with stuff that's on the screen. So as we lose information on the edge of the screen, that darkness fades away. It fades away more abruptly than it should because we're losing the edge of the mountain that is contributing to the effect. Here's off, on, when we have the intensity cranked up. Ambient occlusion really adds a lot. Having this on, it looks good. Motion blur, right? Tons of motion blur. I think that this might not work in the editor. It might not only work in the gameplay. Not gonna worry about that. Translucency, no, not gonna worry about that. Film grain. Film grain's an interesting one. If you're making a game that has like a nuclear reactor and you want to make the player feel like they're walking into a nuclear reactor, you can crank up the film grain to like 10, and then we're being irradiated. I don't know how clear this is to you guys on Discord because it's just crazy noise and the video encoding is not going to capture it, but it feels like I'm being blasted by like a lot of radiation right now.
It definitely does.
So yeah, film grain. Path tracing, that's not relevant. Path tracing is not something that we're doing in Unreal Engine for real time. Path tracing is when you're making cinematics in Unreal Engine and you want to like actually simulate light bounces very accurately. So yeah, these are all the effects. If you combine things like film grain and chromatic aberration when your player is damaged, or maybe when the faster that they're moving, the more chromatic aberration there is, you can get some really cool effects. You crank up the bloom and it feels like it's a different game. You know, you can really make it feel like an interesting game by turning some of these effects on and off. A lot of games do a lot with post-processing, and it's very, very inexpensive to add post-processing. In fact, I'm going to import a random image that I'm just going to use. I'm going to use the Develop logo as screen dirt effect. Let's see, Develop UF. And then if I drag this into the dirt mask texture and I turn up the intensity, interesting. Yeah, you probably want like an actual dirt texture, but oh man.
Yeah, it works.
Desaturate it maybe. Oh boy. Yeah. Interesting. This usually, you really just need like a random dirt texture. The reason that I brought up Asphalt 8 is because Asphalt 8 really overdoes this effect as well.
I see.
It's this game on mobile phones. It's doing a lot of that on the edges of the screen. That plus motion blur really adds a lot. Yeah. Okay. Yeah. Okay. So we've covered post-processing. We have covered a little bit about lighting. We covered shadows. We talked about Lumen, which is the ray tracing solution. There's a few different types of lights in Unreal Engine, right? We got point lights. We've got directional lights, which just add lighting to the entire world. Rectangle lights, which illuminate from a square. So they're sort of directional, and you can simulate like a computer monitor or something. We've got skylights, which capture a 360-degree perspective of the sky and then project it onto the entire world, ignoring shadows, so they go inside of surfaces. Right, so all the illumination that we're getting in here, ray tracing is currently disabled. So the reason that we're getting illumination is because of the skylight. And if I turn up the skylight intensity, there we go. We're getting ambient lighting, you know, and I must have turned it up way too much because the sky is dark from how bright the ground is. Let me turn this down to like 10. There we go. Now we're getting illumination even in the allegedly dark areas of our world. You can tint the light. So if you're doing like a game that's got fake nighttime, you can make the skylight be this dark blue effect, and then your entire world gets dark blue lighting. And you can make the sun, or in this case, what would be like the moon, like a bright yellow kind of light, and you get this interesting noir of you know, like nighttime. If we turn down the intensity, it's already actually supposedly pretty dark. So just like that, and then rotate this like that. Yeah, this isn't. I'm not really able to convey exactly what I want to be doing here. But if we tweak the exposure settings inside of our post process, we could achieve a bit more of a nighttime effect. So let me make this unbounded. Unbounded under volume settings. There we go. So it's affecting us no matter where we are. And if I go under exposure, we can turn up the min EV so that it's like, yeah, it's nighttime.
Huh.
Yeah. But like if you're making a detective game or a stealth game or something, this is sort of the vibe that you might go for, because blue is like fake darkness. You know, people are used to seeing blue and thinking of it as like dark, but it's, yeah, you can still kind of see what's going on in the blue environments. Yeah, okay, so cool. Lighting and post-process settings very quickly let you achieve some cool effects. Okay. Again, see the difference between convolution and normal bloom. This is normal bloom. This is convolution bloom. We get these like cool bands of light coming out of different bright spots on our screen. You can really see that here with this guy, or with the moon. Standard, convolution. Convolution, significantly more expensive. It takes a bit of a frame rate hit, so maybe worth avoiding. Yeah, okay. What else did we want to cover today? Looking back at this, we talked about lighting, volumetric effects. We briefly discussed post-processing. Let's talk about some of the more functional sides of things. So sound, trigger volumes, and terrains. I'm going to cover terrains a little bit. So the terrain tools in Unreal Engine are pretty cool. Let me go to unlit mode. It's actually a little too much detail lighting. Oh boy. Let's do lit. And I will delete this post-process volume so we go back to default. There we go, our eyes are adjusting. That's funny, I deleted the post-process volume, but we're still like blue. Oh, it's because of the skylight. Let me change the light color in the skylight. There we go. All right, back to a normal environment, relatively speaking. Turn down the intensity. Let's go to the directional light and turn up the intensity back to like a normal daylight. Nice, cool. It's still got a bit of a tint on it, but that's okay. So the next thing that I wanted to address, landscapes. With landscapes, landscapes rely on the landscape material. If you came for the material lecture earlier, there's a lot of kind of important ins and outs to making a landscape material work. I'm going to make a new folder, and I'm going to call it landscape stuff over here. And I'm going to switch to landscape mode right here. And I'm going to make a new material in here. I'm going to call it landscape material. Now, the thing with landscape materials is, first off, the thing with these is there's a couple special nodes that interact with the landscape system. If I start typing landscape inside of the material editor, we get all of these over here. We get landscape grass output. We get landscape layer blend. We get all sorts of things. We get landscape layer switch, right? So what this is doing, these all interact with the layer system. So the way that you paint different things onto the surface of your landscape is using this layer system. If I've got the landscape selected right now, so if I drag this into the landscape material slot, the landscape is now using this as its material. And I go to paint over here, it's telling us this layer has no info assigned yet. You must create or assign layer info before you can paint on this layer. And there's no layers that it's respecting. If I go in here to landscape material, and under landscape layer blend, I click plus, and I say new layer. I can make a layer here called sand. And we'll say sand is going to be this 3-vector color, this thing right here. Nice. Sand. And maybe I will make another landscape layer, and I will call it grass. Grass. Nice. And I'm going to plug this into base color, and I'm going to copy and paste this color value and make this green, and this will be our grass material, like that, or grass color. And now what this is going to do is, oh, and then one more thing, let's do landscape layer switch. I'm actually I'll get back to that. So yes, apply the changes. Okay, there we go. Ooh, now look over here, we got these layers and I can start painting them. So by default, the entire landscape is, I think, sand. Now, notice it says none. So if I start painting, nothing's happening. What this wants is it wants somewhere to store the data of where there is sand and where there is grass. So I have to click plus over here, declare that this is a weight blended layer. Weight blended means that it's respecting it as a weight value, and it's looking at which of these is weighed heavier to decide what a pixel is going to be. If this was not weight blended, it would be treated as a layer in a stack, where if you erase the sand, then the thing beneath sand is always going to be stone, and the thing beneath stone is going to be bedrock or something. You can create a layer system. But here we're going to do weight blended. That's kind of the default. I'm going to put it under landscape stuff. I'm also going to click the grass, click the plus button, landscape stuff, and there we go. We've got these layers. And now if I click this, I can start painting. There we go. We're painting in grass. I can turn down the brush size, turn the fall off down, and paint. Let me turn up the strength. There we go. And I can paint a path into our landscape. Nice. Great. Very cool. Grass. In fact, I kind of want the whole landscape to be grass, so I'm just going to do that. Nice. Very cool. I don't like how the sun looks right now. It's not very aesthetic. So I'm going to switch to selection mode. I'm going to click the directional light and make it be a little less yellow. There we go. All right. Here's our landscape. Oh no, it's also kind of shiny. Grass isn't shiny like that. Let's go back to the landscape material and make some adjustments. So I can make another landscape layer blend, and this is going to preserve the exact same names. It's just going by the names of the strings here. So sand, grass, it treats them as unique. I can plug this into roughness, and I can say, oh, sand should be shiny, maybe a roughness value of 0.3, whereas grass should be pretty diffuse, pretty rough, like that. Save, apply, and now we go back to our landscape. We can see that the grass has a dull effect on it now, but the sand is really shiny. You can see that in the sun reflection, right? Disappears, appears. You can see the shininess of the sand. Cool. So, yeah, also this glow that we're seeing here is related to the volumetric in-scattering that we were setting up earlier. So if I go to exponential height fog and I change this scattering distribution back to 0.2, that disappears, and now we have pretty normal volumetric lighting. Very cool. Very cool. So grass, great. Now earlier you were talking about cliff faces. During the material discussion earlier, we talked about how cliffs are created automatically by some landscape materials. So yeah, that is something that you can do. What we can do is we can take the dot product of the normal, so vertex normal, or perhaps we'll do pixel normal. Pixel normal, dot this with the global up vector, which is just 0, 0, 1, like so. And then contrast, and based on this, we can switch between grass and stone. Stone has a roughness value of what? I don't know. We'll say 0.5. So this will be the roughness value of stone. And then we can make another lerp node over here for grass, and we can say switch between grass color and a stone color, which will just be some sort of gray. Excuse me. There. Boom. Save, apply. And now, you can see that, okay, we have it backwards. So things that are facing upwards are stone, and things that are facing sideways are grass. Let's also turn up the contrast. So I'm going to set this to like a value of like 2. Save that. There we go. So see, we're kind of generating cliffs, but we have it backwards. There's grass where there should be stone, and there's stone where there should be grass. So we can, what we can do here is we can just invert this. We can do 1 minus, and that should fix that. There we go. Boom. Automatic cliffs. So now, if I go back to landscape, I am able to, sculpting. There we go. These cliffs automatically get generated. Nice. Cool. Very nice. Aesthetic little effect. You can see how easy it is to build a Mario kind of vibe into your world using just really simple pastel colors. Great for game jams. Especially if you use this like flatten brush over here. You can make these like really aesthetic kind of round structures like that and kind of get this Mario style going. It's definitely important to go back and click smooth on them a little bit to erase some of the crustiness at the edge of the landscape. But yeah, there we go. Nice. Very cool. Yeah, now there are better practices here. So you guys saw this, and it's already becoming a mess with just a couple different layers. You know, maybe you get to the point where you want to add a path. So I'm going to teach you the best practice before we move on. And the best practice is to use material attributes. You click this, and now our outputs have been reduced to a single node. And this node is supposed to be all the material attributes. So what we're going to do now is we only need one landscape layer blend, like this. And downstream of this, or upstream of this landscape layer blend, we're going to do make material attributes. And now we can just treat this as a blend of multiple different materials. So we have our sand, we have our grass, we have our stone, and we can just keep adding layers like this. Add another, let's see, stone layer, stone, and put it there. And pretty much upstream of this, we would do all our work of mixing things together. So this guy over here, I'll name him grass. Grass is going to have this color, and grass is going to have this roughness value of, you know, it's 0.1, and it's going to have a metallic value of 0, and it's going to have, you know, whatever, maybe it glows, I don't know. Sand can be over here. Stone can be over here. And you see that this significantly organizes the workflow. Now, one more thing. Landscape layer sample. What this does is it says, hey, let's sample the sand, or the sand. Let's do the sand landscape layer. And what we're going to do is we're going to output grass. So what this is saying is this plugs into a automatic like grass distribution system. So we're going to say where there is sand, place quote unquote grass. Grass is referring to any foliage type. So over here it's like, oh, okay, add a foliage asset. Oh, you don't have a foliage asset. So what we're going to do is we're going to go over here and go under foliage, and this is going to be a quick introduction to foliage. Foliage, effects, foliage, material.
Above effects.
It's above effects. Oh, I'm blind. Good man, good man. Landscape grass type. And I'm going to call this sand scatter. So this is the stuff that we want to scatter on surfaces that have sand. I'm going to put like cacti, little cacti and little rocks. So I'm going to crack open Blender over here just to make a little cactus real quick. Maybe maybe an icosphere, like this. And then like that, maybe. I don't know, cacti have kind of goofy shapes. Yeah, cacti have really goofy shapes, man. There we go. Well, cactus like that. Join all of this together. Maybe give it some spikes, like so. Oh boy. I meant these to be uniform. Oh god. Hold on. Copy to scale, tab I. Okay, that didn't quite work. Maybe if I do individual origins S 0, M distance, Control Shift B. Oh, okay, yeah, this is kind of working, and then I can just extrude little spikes out. There we go. Cool. Cactus. Okay, and then
It was like enchantment table speech, and you just made a cactus.
Let's do desktop. We'll call this cactus.fbx standard object, export, and then back in Unreal Engine we can grab that. So let's import it. Import from desktop cactus abc. There it is. Import, and we got our cactus. So under sand scatter, it wants me to describe what sort of grass we're working with. So I'm going to say, here's the cactus grass. And if I go back to the landscape now, oh yeah, let me go back to the landscape material. And let me plug this in over here, sand scatter, save. And what should happen now is it should say on the sand, oh, yep, there we go. Woo! Oh, for some reason it like inverted what isn't sand. Oh, it's kind of wild. Oh, yeah, hold on. Grass, sand. I got these mixed up. There we go. Save. And then back. All right, so we've got sand scattering these like cacti meshes all over it. Very cool. This is absolutely destroying my frame rate. So let's play with the density. We can go over here and say grass density. Maybe instead of 400 per like square meter, we can do like 20. And we go back. That's still a lot of cacti. We can play with their random.
Might just do one. Or like
yeah, just one might be right. Yeah. There we go. Cacti. And then we can also maybe increase their jittering effect and the distance where they show up. We can make them cast shadows. We can make them affect distance field lighting, which means they're going to contribute to distance field ambient occlusion. And we can also probably, we can probably turn this down to like 0.5. What else? Save this. Now, it's very important to know that these don't have collision or anything. They are just there to be like a visual effect. So you probably wouldn't use this for cactuses because cactuses like probably need to be destructible and like bumped into. You would use this for really small pebbles or really small like grass. So if we wanted to actually create like a more of a grass effect, we would use like a plane, right? Like if I go to Blender and I just export like, oh god, come on Blender. Blender actually has like a much longer startup time than it used to. Here we go. Maybe it's just not on my SSD. So if we export like a little plane like this for grass, maybe grab z 0.5, there we go. Maybe a plane that kind of looks like this, and maybe, you know, this is sort of how grass is modeled in games, right? This is like the vague effect that people go with is kind of something like this, little patch of grass like that. So you would export something like this, and you would place a bunch of these little grass planes all over the place in Unreal Engine. And it creates a very good effect very quickly. So grass, you can achieve that pretty easily. So again, how is this working? We're sampling where there is sand using this landscape layer sample. And we just plug in the exact name that we're using for the layer, and we output into landscape grass, and it respects that. We can have a separate output for a different layer. So if we wanted to, say for our grass layer, grass, we can have a different output, and we could just use a different grass type. So under grass types, we've got grass, we've got maybe well, we'll do this grass, and this should probably be sand. The names here don't matter. This is just like the strings that it's using, but they're not related. Oh, I think that accidentally got rid of our cacti. Oh, they're both plugged into the same thing because of the name change. That's funny. There we go. There we go. So yeah, we could probably have a separate grass for the actual grass here, but I'm not gonna set that up right now.
So are the cactus like spawning in and going away, or is that just like the distance rendering?
It's the distance. So it's preserving the locations where they should be, but it's like dynamically spawning them based on how close you are. We can play with that setting.
Gotcha.
So under cull distance, we can say that the culling distance should start not at 100 meters, but at 1,000 meters. If I hit save, we go back. Oh,
It's not gonna work.
Did I stutter? Oh my. End cull distance. I think end cull distance is the one that matters. Yeah. So start cull distance is like where they should start fading out. End cull distance is where they should stop fading out and totally disappear.
Gotcha.
But as you can tell, they sort of abruptly fade out. So it's like, okay, what the hell? What's going on? And what's going on is the cull distance is actually accessible inside of the shader. So if we gave our landscape or our cactus a material, we'll call this cactus mat, and we gave this to our cactus, like so. We go back to cactus mat. We can grass. I think it's per instance fade amount. I think this is saying, yeah, outputs a float value associated with the amount of fade applied to an instance static mesh like foliage. It is a constant, but it can be a different number for each individual instance of a mesh. So this is going to fill in the data about like where, you know, how much it should fade out. If we plug this into the color, we're probably going to get an idea of what's going on. Oh, no cactus? So, okay, that might have killed it. Maybe, hold on. We'll do black cactus for a second just to make sure that's the glitch. Are we working? What's going on?
One actor with grass maps needs to be rebuilt. Not this.
No, that's been there.
No.
Something else happened. Oh, I think I just had to update the density for it to like regenerate them or something. Let me give it back the material like that. Save. We good? Okay, we're good. So these guys out in the distance should be getting darker based on the interpolation between start and end cull distance. So if I make this 0, we should see a fade from like white to like darker, but honestly I'm not seeing it, but that's theoretically how it should work. I've achieved this before. I don't remember exactly how this works. But
Might take
anyways,
some fiddling.
yeah, it takes a little bit of filling. Like look up the documentation, you know. I'm trying to speedrun to give you an idea of what you can do, but admittedly I'm not able to do everything perfectly.
Yeah, I remember seeing something like this before in the other tutorial where they were spreading a bunch of ferns everywhere. And there was
Yeah.
somewhat of like a render distance. The further away they were, the like lower quality they were, and then as you got closer, it
Yeah.
was different.
Yeah.
And another way they kind of went about that was they just used everything as nanite, and then it was just the same like everywhere, and it was performance efficient.
Yup. So there's Nanite Foliage. So Nanite is the Unreal Engine feature that lets you like have unlimited triangles on your screen more or less, and automatically tessellates things so that it maximizes the amount of detail without really sacrificing performance too much. It's pretty awesome, and
would it work on the cactus?
It would work on the cactus. So what we could do is we could do a new foliage type. We'll call it static mesh foliage, and we'll use we'll create a new type of static mesh foliage. And this static mesh foliage will use the cactus. And now we can paint foliage onto our world, hopefully. Actually not able to see my brush. Oh, I have to check it. There we go. So now we're painting foliage on. Nice. There we go. Boop. However, not clear to me if this is using nanite or not. And I think that
if you right click it in the window, like on the bottom. And then oh wait.
I don't think it's in there.
No, I think you have to have it like in the select thing. What I remember doing is like I could right click it, and at the top there's a checkbox to turn on nanite. And there's just like a tab there.
I'm guessing it's in here somewhere. There it is. Enable nanite
There you go.
support. So if I click that and I click apply, there we go. So now it's generated nanite stuff for the static mesh. And now all of these meshes have nanite. I have a feeling that this might get in the way of the landscape grass effect. Yeah, I don't know if landscape grass supports nanite, but we're working.
Oh, it does.
It does?
I think it might be. Yeah, you might have to like redo it. I don't know. I know that you can, but if you're using like different models to do it, you'd have to go and update that other model as well. So like, you might have done it for the instance, but not the actual original cactus.
Let's see. Oh, there we go. I just had to like reset it. There we go. So these are now using nanite as well, and you can see nanite kicking in because the spikes. Look at this. The spikes just appear when we get a little bit closer.
If you go into like the lighting or something, you can change it to be nanite, and you can see all the triangles.
Yep. We can do visualize nanite, and maybe if we do nanite under triangles, there we go. So this is everything that's nanite enabled in the scene. We can see as we get farther away, a bunch of LODing takes place, and as we get progressively farther, we're going to see fewer and fewer triangles as well. So it's combining them together. Pretty
cool
sick.
Little visual.
And yeah, and we're able to see the foliage from like infinitely far away without it costing any performance, which is insane. Absolutely insane. Praise be to the engineers at Unreal. Yeah,
yes, sir.
So infinite density, like no lag. Oh boy. Oh no. What have I done? Is the density a little too high? What have I done?
I know sometimes like the density, if it's like, oh, you can have this many cactus in this area, and then you can't paint it because there's already that many cactus from when you were painting earlier.
Yep.
Okay, yeah, there you go.
There we go. Absolutely no performance hit right now. That's crazy. That's so crazy, man.
Except for when you place them.
Yeah, when I place them, but otherwise, my frame rate is actually not suffering at all. That's so awesome. and yeah, you're right. It's not letting me like
magic.
Contribute to the density because there's already like you can see the freaking crop circles that we're painting in. Yeah, nanite. So nanite does have like a flat performance cost for enabling it, but if your computer can sustain that, then it can sustain all the added features of nanite. There's a lot of settings down here with foliage that also can automatically disable you from painting foliage on certain angles. So notice how we're not able to paint on the hills. That's because it has a maximum angle of 45 degrees. If I had turned this down, this would have prevented me from painting even more. So now if I try to paint again, it's only placing cacti at the tops of the hills. So yeah, cool. Those are foliage tools and nanite. Thank you for convincing me to show off nanite real quick. It really flexes the power of it.
Oh yeah.
What else? What else? What else? What else? I know it's almost 7. We're almost out of time. I said I would talk about navigation meshes. That's an important feature. So if I go over here and do a nav mesh bounds volume, navigation meshes are a big part of placing any AI in your world. What nav meshes do is they sort of create this triangulated grid that can be navigated with a pathfinding algorithm. I know there's a way to visualize the navigation mesh. I think we have to do show navigation. Yup. And then if I press P, yeah, okay. Oh, well, the nav mesh is green, so it's kind of hard to see. But this is the nav mesh. You can see the bounds of it there. So what this is doing is it's detecting flat, contiguous pieces of ground that like an actor could theoretically walk on top of, and it is generating navigation accordingly. There's settings for it. So if we go down to supported agents, no, I guess not quite. The navigation settings are, I think, let's see, nav modifier, nav system configuration override. There's a lot of settings here. Nav link proxy, these are cool. If you ever played Doom, in Doom the imps like jump from different spots. So like if you wanted to make it so that an enemy can go from here to here, because these are like disconnected meshes, you can set that up, and then you can make it so enemies that come here know that they can bounce and come down here.
And they'll like make a jump animation or whatever.
Exactly.
Use that as like a bridge spot.
Exactly. Bridge different disconnected pieces of a nav mesh. Yeah, I guess a nav system config override is probably what we're looking for. And then you would describe that, yeah, there's probably like a type of class that you have to generate, something under, let's see, probably under AI or and miscellaneous navigation might be in here. LMNOP. I don't see it in there. It's one of these in here somewhere. Can I just start typing? Nav is the search. Yeah, it's somewhere in here. It's somewhere in here. Take my word for it.
Wait, what's it called?
Something related to navigation meshes, like a nav mesh config. Maybe under blueprint class. Very good chance that's in here. Yeah, nav. There we go. Navigation mesh config override. Nice. So now we've created a class of this type, and then all the class details are going to be over here, so we can describe things like generic navigation system config. Yeah, the settings, I don't remember exactly where the settings are, but you can look it up. You can essentially describe like how fat your character is, how much of a vertical step they can take, like all sorts of qualities like this, so that the nav mesh can decide like, oh, a character can fit in this crack between this surface and this surface, or a character can't. You know, a character can walk up this hill. If you're making a zombie game, you need navigation meshes for AIs to be able to like walk around. That's how they decide like if they can get to a location or not. So setting up a good nav
meshes are like critical for NPCs and stuff like that.
Utterly critical, yeah. Nav meshes are how pathfinding works. If you don't have a nav mesh, then the most that you can do is just make an NPC walk directly towards you, and they'll just try to walk into a wall if you're on the other side of the wall, right? So that's nav meshes. What else? Okay, we covered nav meshes. I want to make sure I cover everything that I vaguely wanted to. We covered grass, water. So the fastest way to do water in Unreal Engine is to use the pre-made water system that they have for Fortnite. It's a bit of a high quality system. If you go under plugins, right, edit and then plugins, there's a lot of like chunks of Unreal Engine that ship with it, but they aren't enabled by default. And so in here, if I look up water, the full suite of water tools is available by just checking this. It's going to force me to restart the engine though. There's a lot of plugins, and some of them are really useful. We've got Paper 2D. If I disable this, I can disable 2D features. Like if you're not working with tile maps and all of that stuff, then you don't need this. So it's a good idea whenever you're making a big new project to, disable some of these learning agents, right? A machine learning library, very cool. Mass AI. This is for like having giant crowds of AIs that are aware of each other and collide with each other. They can like avoid each other, do crowd navigation. Augmented reality stuff. Yeah, you see, there's a lot of plugins. If we go under effects, Niagara fluids for doing fluid sims with the particle system, so your particles actually behave like waves and stuff. Gameplay, yeah, there's a lot of stuff in here that by default just isn't enabled, but you can turn on to make use of it. A lot of it is experimental, that's why it's not enabled, but not all of it. Not all of it. Some of it's pretty reasonable and pretty useful. LiDAR point clouds, like there's so much stuff. Yeah, so I enabled the water plugin. It's gonna make me restart the engine now, but I will show that off real quick. So let me save everything, restart, comms. I'm gonna go eat. I can be here for the 7 p.m. talk. Awesome, good stuff, Mike. Unreal Engine's restarting. Oh boy, because the water system has a bunch of shaders, it's actually recompiling those shaders. So 800 shaders left. It's counting down.
Oh no.
700, 600. Okay, it's going pretty fast. Unreal Engine used to get made fun of a lot for how long it took to compile shaders. Ever since like Unreal Engine 5.2 or something, they fixed it. But before that, Unreal would have like a 40-minute startup time when you first opened it.
Oh, that is.
Well, only when you first open it, like the first time ever. After that, it'll open like.
Oh, okay.
But whenever you started a new project, you just had to wait like for 2 hours. It's pretty frustrating.
Wake up, start it, go back to sleep.
Exactly. Yeah, no, literally like compile 8,000 shaders. Okay, so we've got the water system in now, and if I go over here and I look up water, look at that. We got water body ocean. And this is going to be really nice. Here it goes. Come on. Come on. There we go. Look at that. Stunning water. Gorgeous, insanely good-looking water. Wow. Beautiful. And what it's done is it's adjusted the landscape using this blueprint brush here. So there we go. Insane. Beautiful water system with waves that are, I think, FFT waves, not... Oh, no, they're not. They're tiling, so never mind. But you can create a shoreline, and you can make it interact with the shoreline in a healthy way, and you can make the wave release, like, foam and stuff. There's so much cool stuff that you can do here. Under the water settings, like, God, there's really a lot that you can do. Audio, it even plays audio. That's crazy. I haven't actually messed around with this very much before, but you have a lot of control. You can make rivers, and the rivers...
That looks amazing.
The rivers will automatically interact with the ocean. They will flow out into the ocean appropriately. Here we go. There we go. Boom. River, seamless into the water. And then, yeah. It's okay, but I think it could probably use some
Yeah, it
tweaking.
seems like it might be flowing the wrong way.
Yeah. Yeah, it just might be. But it does expose a lot of these shaders. Oh boy. No. I'm sure there's a lot of controls in here to make it more powerful or less powerful. It will interact with your player though. Like you can generate waves behind it if you swim in it. Yeah, you can do a lot of cool effects. It even, look at this, it automatically creates post-processing for when you're beneath it as well. So we get a post-process effect when we're under the water and versus when we're above it. There's definitely, I know that there's the ocean, there's definitely settings to make it look better or artistically control the effects of the water, because I don't like my water looking this blue. It's a little bit unrealistic, you know, that like maybe we want a more tropical effect, maybe we want it to have like more gentle ripples. There's definitely settings for that. I bet if we go into the ocean material, here we go. Here's the settings. So yeah, okay, here we go. Lots of stuff to control in here. So if we start tweaking these settings, oh my god, you can do foam, you can change the color of the water, the scattering effect. My god, there's actually so many settings. Wow. Jeez.
I can't see the settings.
Yeah, I know they're on my other screen. They're on my other screen, but we can turn up the normals. We can turn down the normals. Wow. Yeah. Okay. I'm like impressed. There's really an insane amount of tools here. You can turn on foam. Sheesh, man. There's actually, wow. There's so many settings. Wow. 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 Yeah, you can change the water color. Here we go. Absorption. Orange, maybe? No. Oh! Okay.
Oh, there you go.
Yeah, that's not quite what I had in mind, but I mean, you can see
how
this
looks like the ocean.
Yeah, I made it orange for some reason on my end, and I guess it decided to treat that as like vaguely black. There we go. Red. Blood red. Yeah. Yeah. But yeah, yep. Big water system. So just know that that's available to you to mess around with. I think we've covered more or less everything that I wanted to cover. I did not have enough time to go over actually like the player start. Player start is like an object that you can place and it will be respected as the initial spawn point of the player if your gameplay framework stuff is configured correctly.
It's just like a hitbox you put into the world.
Exactly. It's like it's a spawn point, but it's respected. Sound cues, it's just like a sound object. You drag it in, you can attach an MP3 file and say just loop this. So if you have like a fountain in your world, you just place a sound cue there for the source of the fountain. There's a lot. You can do a lot. But yeah, we covered some of the key ones, which was post-processing, terrains, and foliage, which I think is some of the most important stuff by far. But yeah, okay, I'm gonna go ahead and end this. Any questions? I know that's been kind of a non-stop one, but yeah,
I'm kind of hungry. I'm gonna go grab a slice of pizza. I'll be back.
all right. I'll wait for a minute. We'll start the next one at like 7:20. A little bit behind, but that's okay.
All right,
Go
gotcha.
over the UI system. Cool. Delete these project environments. Bye. Man, I have so many like demo projects that I've been cranking out. How are the rest of you guys doing? Stop the recording.